All right, so let's finish up chapter 14. We're going to go to I'm going to share here. Let me get over to here. All right. So let's get over here. Let's try that one more time. There we go. All right, so last one, okay? Believe it or not, this is it. It is on dilations. 14.3, a dilation, a little bit on constructions and the application of dilations. Now, this is the only one that is not an isometry, okay? The isometries, remember, keep the same shape and size. Nothing changes. But under, so an image under isometry is congruent. We talk about that. A different type of transformation is created when a slide is projected on a screen. The objects on the screen are enlarged from their original size on the screen and the same factor. Okay, so when we look at something like this, okay, you have a small picture that's in your screen, your projector, but when it projects, you have a size that's a scale factor of 20, much bigger on the screen. Okay, this is an example of a dilation. Now, some people say dilation is getting smaller, but it's actually getting smaller or getting bigger. Okay, if the dilation has a scale factor of over 1, then it's getting bigger. Okay, if it's of a fraction less than 1, then the shape is getting smaller. Okay? Now, it says each side of A, B, C prime, A prime, B prime, C prime is twice as long as the other. Okay, so if we take this center, okay, of the dilation, which is O, and I have A, B, C right here. Okay, I want to make A prime, B prime, C prime twice as big. Okay, so what we then do is we take the distance from O to A. Let's do that again. All right, so we're going to take the distance, oops, clear all that out. Take the distance from A to O, okay? And then we take that distance and double it, and we get all the way up to here. That's going to be 2 times as big, okay? So that's that point. So we've now dilated that point to A prime. Then we do from O to C, and then since it's a scale factor of 2, or twice as much, then we take that same distance again, get to C prime at the same angle, up 2 over 1, up 2 over 1. And then for B prime, it's up 2 over 4, so we get to here, and we double that, and we get it out to here. Oops, we get it out to here. And then we connect A, B, and C. Now notice, it's still the same shape, just not the same size anymore, so it's no longer isometry. Okay? A dilation from a plane to the plane with center O and scale factor greater than 0 is a transformation that assigns each point A to a point A prime. Okay, notice it has to be bigger than 0. Okay, anything less than 1, bigger than 0, still a dilation, that's a fraction. It is possible to find a dilation when the scale factor is negative in the same way as in the preceding definition of the positive scale factor, except that O must be between A and A prime. In other words, you'd have to go the opposite direction from where you started. Find the image of the quadrilateral ABCD under a dilation with the center O and a scale factor of 2/3, which means we're making it smaller. Okay, so here is ABCD. And so from the distance from O, right, so from the distance from O, if I take the distance from O to A, I'm going to take only the 2/3 of that distance. to find A prime. And then I take the distance from O to B and only take 2/3 of that distance and mark that. Same thing with all of them until I get my new shape, which is smaller. So as you see, it would give you, if it's smaller, you get a smaller figure if it's less than 1 scale factor. Okay? All right. A dilation with center O and scale factor greater than O has the following properties. The image of a line segment is the line segment parallel to the original segment and r times as long. The image of an angle is an angle congruent to the original angle. Okay, in other words, an angle, you're not going to have a scale factor of an angle. The angle is still going to be the same size as the original. The segment itself will be however scale factor difference it is. Show that ABC is an image ADE under a dilation. Identify the center of the dilation. Okay, so if you look A to D and A to B, notice ABC, here's ABC, is an image of AD. So we're talking about how ABD or ABC is coming from ADE. So the pre-image is the smaller one, which means we're getting bigger, which means if we're getting bigger, the scale factor has to be bigger than 1. Now, how much bigger it is? Well, if you take A to D right here, that has a group of 2, right? That has a size of 2. And then A to B has a size of 4. Well, that looks like it would be a scale factor of 2. Well, let's double check. This is 3 from A to E, and then from here to here would be 6. So we should have a scale factor of 2, which we do. Okay, now where's the center of the dilation? Everything moves off of A, so A did not change. Okay, so if you get a point that does not change, that's usually going to be your center of dilation. Okay. All right, so get rid of that. There we go. All right, so one way to make an object appear three-dimensional is to use perspective drawing. Okay, this is something they do in art class. Okay, for example, to make the letter C appear three-dimensional, we can use a size transformation with the appropriate center O and a scale factor with the selected images. So here I have the letter C, and to make it three-dimensional, we can send every important point. Okay, our important points would be here, 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 and here, right? And then they picked a point right here, and we're going to draw a line to get to here. Okay, straight lines go through, and wherever I want to make the new C at, we can make the 3D, and we can make this point here. You could do it right here too, here, and then here, and then you have here. Actually, I'll have this point too. So you'd have this point here and this point here, so that you'd come around this way, come around this way, and then this way, and then this way. You make another C. So you can pick any point you want. It's still going to look 3D. All right, show that ABC is the image of APQ under a succession of isometries with a size transformation. Okay, so I'm trying to get to A, B, C right here. Okay, but I'm starting here at APQ. So how am I going to get to here? Well, first and foremost, we're going to have to do one of two things. I can do a half turn. Actually, I can only do a half turn. It's not a slide. They're different shapes, right? It'd have to look the same. It's not a reflection because P would have to be over here if it reflects. So this would be a turn to get to the red, and then go from red or pink, I guess it is, to blue. I'd have to increase it This is 3, that's 3, that's 6. 2 and 2 is 4, so it's a scale factor of 2. So I'm going to have a half turn, which is a turn, halfway, 180 degrees, and then a scale factor of 2 to make it bigger. So you get a combination there. Okay. Therefore, ABC can be obtained from APQ by first finding the image APQ under a half turn, that's what we said, and then a scale factor of 2 on that image at P, and the center being A. Okay. Now, the other main thing from here is we talked about isometry was congruent shapes. Two figures are similar if and only if it is possible to transform one to the other by isometry, or isometries following the dilation. Okay, dilations are not congruent unless you have a dilation of 0. Okay? Any other dilation makes your shape not congruent, but it does keep it similar. Same shape, different size. All right, and that is the end of the book. How about that? I hope it all helps.